Hi and Assalamualaikum. I am Muhammad dengan HAKIMI dan KHAIRUL AZRIN from YTM Kampus Jasin. Today I will discuss about topic related rates. Definition of related rates. In differential calculus, related rate problems involve finding rate at which a quantity changes by relating that quantity to other quantities, whose rates of change are known. The rate of change is usually with respect to time. So, alright guys, we will continue the example of related rates. The question is, gas is escaping a spherical balloon at the rate of 4 cm cube per minute. How fast is the surface area shrinking when the radius is 24 cm? For a sphere, volume is 4/3 pi r cube and S equal to 4 pi r square, where V is volume, S is the surface area, and the r is the radius of the balloon. In the question, we must to find the value is ds over dt. We had known the value is volume is 4/3 pi r cube and the radius is 34 and surface area is 4 pi r square. So we know dv over dt equal to -4 cm cube over meter because the balloon is decreased. We will continue it. dv over dt equal 4/3 pi times 3 r square dr over dt. So we must simplify the 3 there. So we can get 4 pi r square dr over dt. So we must insert the value of the dv and dt and the radius in there, and we can get -4 equal 4 pi 24 squared dr over dt. We want to find dr over dt, so we will move everything to the left side and calculate it, and when we simplify everything, we will get the value of dr over dt, which is -4/24 square pi. We will move to the right side. When we find ds over dt equal 4 pi times 2r dr over dt, so 4 pi times 2r we can get 8 pi radius dr over dt. We will insert the value of the radius and the value of the dr over dt. So the equation is 8 pi 24 times -1/24 square pi. So we will calculate and get -1/3 cm square over mean. The conclusion from me is surface area decreasing at rate of 1/3 cm square per mean. I hope you all understand what I discuss of this topic. We will continue to the next topic. That's all from me. Thank you and arigato.
Apply maximum and minimum. What to solve? How to build a rectangular pen with 3 parallel partitions using 500 feet of fencing to find what dimension will maximize the total of pen. First step, let variable x be the width of the pen and variable y the length of the pen. Next, the total amount of fencing is given to be 500 equal to 5, which is width, plus 2, which is length, and equal to 5x plus 2y. So that will be 2y equal to 500 minus 5x, or to be much easier, y equal to 250 minus 5 divided by 2x. Second step, before differentiate the right hand side, we will write it as a function of x only. Substitute for y getting a equal to xy, then we will get x in bracket 250 minus 5 divided by 2x, we will get 250x minus 5 divided by 2x power of 2. Third step, now differentiate this equation. A prime equal to 250 minus 5 divided by 2x, we will get 250 minus 5x, then we will get 5 in bracket 50 minus x, then we will get 0 for x equal to 50. Note that since there are 5 lengths of x in this construction and 500 feet of fencing, it follows that 0 less greater than x less greater than 100. See the adjoining sign chart for A prime. If x equal to 50 feet and y equal to 125 feet, then A equal to 6,250 feet power of 2.
So now we move to topic 5, that is application of integration. So in this chapter, what I'm going to explain is area between curves. So let's get started. So firstly, what is integration? Basically, the integration is the process of finding the integral for a function at any point of the graph. The integral usually called the antiderivative because integrating is the reverse process of differentiating. So this is the integration symbol, as you can see here. So area between curves. In this section, we will take a look at one of the main applications of definite integral in this chapter. We will determine the area of the region bounded. So now we are going to look at the example of the question. So here is the graph, and the problem statement is find the area of the shaded region. So this is the shaded region from the graph. So firstly, what we need to do to find the area of the shaded region, we need to apply this formula. This is the formula on how to find the area of the shaded region. So now, using the formula above, we need to substitute the top function that is here, the top function, and the lower function. These are the lower function. And now, also I forgot, we need to find the lower boundaries and the upper boundaries. So we can get the lower boundaries and the upper boundaries based from the diagram, from this figure 1. These are the lower boundary and these are the upper boundary. So when we substitute, and then we get the new function. After we substitute the top function and the lower function. So next, we need to, after we done subtract the top function and the lower function, now we apply the integration into the equation that I have got just now. This one, we need to integrate this function. Okay, now we are done integrate the function. What we will do next is we will substitute the lower boundaries and the upper boundaries. So this is the result of substitute the lower boundaries and the upper boundaries. So now what we will do is just calculate the function that is we have substitute the lower boundaries and the upper boundaries. And now we can perform the calculation. So you can use your calculator to check the answer if this is right or not. Okay, this is the final answer for the question. Thank you.
Hi, in this video I'm going to show how to find the volume of a certain curve when it rotates at about x-axis or when it rotates at about y-axis. There are 4 ways to find and determine the volume. One of it is the disk method. So now I am going to explain the concept about the disk method. So let's say there's a curve like this and boundaries A and boundaries B. When the curve revolves around the x-axis, we have to imagine the three-dimensional cross-section of the curve. So it will be like this. From point A to point B. So if you notice, the disk produced is a cylinder. So right here would be the radius. So right here will be the radius. Here will be the height, and here will be the height. So to find the volume, we must know the volume of the cylinder. How to find the volume of cylinder? V equal to the surface area A times width height. So the surface area is actually pi r squared times height. Then you want to find the volume of the disk along the curve from point B to point A. So all you need to do is to integrate the surface area like this. You integrate surface area from point B to point A, and then as you notice, the radius is equal to the height of the y-axis, and it is present by the function that will be given. And also the h is actually equal to the dx. So the formula is actually p pi r squared fx squared dx. Since pi is a coefficient, we can bring it out. There are two cases. The first case is when the curve move around x-axis. The point will be A and B, and the shaded area will be here. So the volume will be pi integrate B and A fx squared dx. The other case is when the curve rotate around y-axis. The point will be C and D, and the shaded region will be here. Since it rotates around y-axis, the function will be in terms of y. So the formula will be volume equal to pi integrate d to c fy squared dy. So now let us try with a question. The question gives us the equation of a curve y equal to 1 over 4x squared and point x and y, and it's about y-axis. So we know that this curve are going to revolve around y-axis. So first we have to sketch the graph. Y equal to 1 over 4x squared will be like this. Over 4x squared. So given point is 1, y equal to 0 and x equal to 2. So since it revolves around y-axis, the formula that we are going to use is v equal to pi integrate d to c fy squared dy. So the point are going to be from here to here, but we don't know what is the value here. So but it already give x equal to 2. So when x equal to 2, we can find the value of y when we substitute the value of 2 into the curve equation. So when we substitute the value of 2 into the equation, y will be equal to 1. So now we know that the boundaries is between 0 to 1. So how about the equation? The equation, we must change it in the terms of y. So it will be like x will be equal to square root of 4y. Then all we have to do is substitute all the information we have get into the equation. So pi integrate 0 to 1 fy squared will be square root of 4y squared dy. Then the power and the surd symbol will cancel out each other. Equal to 4y dy, and we integrate 4y. We integrate 4y will be 4y squared over 2 1 to 0. And then we are going to substitute the 1 and 0 into dy. So pi 4 1 squared over 2 minus 0. Then after you calculate all, then the volume is equal to 2 pi unit cube.
Assalamualaikum warahmatullahi wabarakatuh. My name is AZRIN bin Abdul Munir, and I will be explaining about washing method from the topic volume. So what is washing method? Washing method is a technique to find the volume of a solid of revolution. Washing method is a generalized version of the disk method. Both the washer and disk methods are specific cases of volume by parallel cross sections. So now let us try some problem solving by using the washer method. The question is, find the volume of a solid generated when region between the graph of fx equals to 1 over 2 plus x squared and gx equals to x over 0, 2 is revolved around the x-axis. So now this is the graph that I have made from understanding the question. So the first function, which is the fx, is 1 over 2 plus x squared. So this is the fx. The fx is the outer function because it is the most furthest away from the x-axis, because the question said that it revolves around the x-axis, and y equals to x is the gx, which is the inner function because it is the most nearest from the x-axis. And from the equation, it already said that it has given the function is 0, 2 revolve around the x-axis. So 0, 2 is the value on the x-axis. So this is the 0 and this is 2. So we have the value on the x-axis. And now we need to visualize the solid for this question. So now this is the inner function, so we can visualize it, the area like that, and then this is the outer function like that. So this is the area of the washer. It is called the washer method because of it looks like a washer. So this is the solid, if we can visualize it. So now we need to find the volume of the solid. So let's try to find the solution. First and foremost, we need to find the outer function and the inner function from the graph, which we already did. The outer function is 1 over 2 plus x squared, and the inner function is x. Next, we need to find the value on the x-axis because it revolves around the x-axis to be the value for the integration. So the value that we got from the graph is 0, 2. And then to find the volume, we also need the formula, which is the formula for the volume is pi integrate a to b fx square. Fx square is the outer function, the fx, and minus gx. Gx acts as the inner function, n square and dx. So let us try to substitute the value and solve the question. So this is the steps. So we use the formula and substitute the value that we got which is into pi integrate 0 to 2 from the x-axis value, and then we had to substitute the outer function, which is 1 over 2 plus x square because of the formula, and minus gx, which is the inner function. It is x and then square dx. Next, we need to expand this formula, this value inside here. So we will get 1 over 4 plus x squared plus x to the power of 4 minus x squared. As we can see here that the x squared, both of the x squared have different symbol, which is this got plus x squared and this is minus x squared, which we can cancel both of these. And now we'll be left with 1 over 4 plus x power of 4, and we can just integrate this value now. We will get x over 4, which means because of 1 here is x power of 0, and if we integrate it, it will plus 1 and it will be x. So now after that, we need to integrate x to the power of 4, which is plus 1 over the value from the 4 plus 1 to be as the denominator. Now we will get x to the power of 5 over 5 and 0 to 2. So now we need to substitute these two values into x, which is we will get 2 over 4 plus 2 power of 5 over 5 minus 0. Minus 0 because 0 divide with any number, it will get 0. Next, we can simplify 2 over 4 and be 1 over 2. And we will get 1 over 2 plus 32 over 5, which from 2 over 2 power of 5. And we can solve this and we will get 69 pi over 10 unit cubic. Next, this is the reference that I use for this presentation. And that's all from me. Thank you very much.